Could be worse. Things to forget to record. Last call before we do this homework quiz. Yeah, Alyssa.
Just a quick question.
Sure.
What are the opposites of like tan and then
Yeah.
like tan and then cot and then what's sin?
Yeah. So cotangent is 1 over tangent. Cosecant is 1 over sine. And secant is 1 over cosine. The way that I remember this is that no cos go together. So like cosine doesn't go with cotangent or cosecant. Cosine goes with secant, right? And then once I have that, tangent, cotangent, hopefully you can remember those two go together because they have the same name in them. So sine goes with cosecant then, just by process of elimination. That's the way that I remembered it when I was a junior in high school or whatever when I took this. Okay. Anybody else? Okay. Natalia. 5 on worksheet 1. Sure. So 0, pi over 2, pi, 3 pi over 2, 2 pi. So we're looking at this section. Consulting all silly turtles crawl. I know that we have to be in quadrant 4 because for tangent to be negative. So I know that y over x is going to equal negative root 3 over 1. So I'm going to go to quadrant 4, look for the place where the y has a root 3 in it and the x has a 1 in it. I don't care about the negative sign because I've already accounted for that by figuring out the quadrant that I need to look in. Where did that unit circle go? There it is. So we're in quadrant 4, y with a root 3 in it, and an x with a 1 in it. So we're looking at 5 pi over 3. Sure. Yeah, Josh?
Can you like go over this like salty turtle thing that you're doing? Like, you do it so fast, and I have honestly no clue what's going on.
Sure. So the A, or what this is telling me is whether sine, cosine, or tangent is positive or negative in each of the given quadrants. So A in quadrant 1 says that all sine, cosine, and tangent are positive in quadrant 1. The S in quadrant 2 tells us that sine is positive in quadrant 2, but cosine and tangent are negative. The T in quadrant 3 tells us tangent is positive in quadrant 3, but sine and cosine are negative. And the C in quadrant 4 tells us cosine is positive in quadrant 4, but sine and tangent are negative.
Okay, so that makes
So the letter is just telling us which of the functions is positive in that quadrant. If it's not positive in that quadrant, then it's negative.
okay.
So all silly turtles crawl, or salty turtles, or sexy turtles, or sympathetic turtles, I don't know. Whatever way you want to remember it.
And then wait, so once I get that, like I plug in the pi, that thing, I just apply it to the unit circle and then I get my answer.
So I usually start by figuring out what 2 quadrants this is covering. Then I use the all silly turtles crawl to figure out which of the 2 quadrants I really need.
So what What are they covering?
So from pi to 2 pi is the yellow area that I highlighted.
Oh,
So that's covering quadrants 3 and 4. Of quadrants 3 and 4, tangent can be negative only in quadrant 4. So that's how I figured out my answer was in quadrant 4. Notice that's where the terminal side of my theta is that I drew. Is that okay? So then I'm going to go to my unit circle. Because we're talking about tangent, I'm going to find where the y-coordinate has a root 3 in it, and the x-coordinate has a 1 in it, inside of that fourth quadrant. Oops. Come on. There we go. So that's the spot, right? X has a 1 in it, y has a root 3 in it. So there's my answer.
oh, so your answer doesn't have to be in the quadrant.
It's in quadrant 4,
Oh,
right? That's how I knew to go look for it, was I had to look in quadrant 4 for where that was happening.
and the homework quiz is just gonna be like questions.
Yep. Just from worksheets 1 and 2. Did that?
Yes, that helps.
Okay. We ready to do this thing? Well, I mean, like, okay, maybe you don't want it. 4.3 yesterday when we talked about converting back and forth between bearings and standard position angles, right? Kind of talked about the motivation of what we're trying to do here. So I'm just going to run through a couple of examples of the kind of story problems that we'll have to deal with in this chapter. So this first problem says a boat leaves a port and averages 40 knots, that's nautical miles, for 2 hours on a course of 215 degrees. Then the boat turns to a bearing of 162 degrees and travels at 55 knots for 3 hours. And then we want the distance and bearing of the boat relative to the starting position at the port. So this is kind of the idea of what we're going to be doing here. And then we'll actually do the mathematics, but it's the first time I want to be kind of thorough. So let's say that here's the start. Our ship is at the port. I'm going to place the port at the origin. And the ship here is going to go at a heading of 215 degrees. So 90, 90, and then like 35 more. So it's going to be down here somewhere. Everybody okay with that idea? Some distance. I'm not even worried so much about that right now. Okay. And then I'm going to make like another XY axis. And I'm going to place the new location of the boat at the origin. Because then we're going to turn course at 162 degrees. So 90 and then like 72 more. So we're going to be down here somewhere. Everybody's okay with that? And it's asking here for the distance and bearing relative to the port. So then we're looking for basically this bearing. And the distance is going to be like that length. Is everybody okay with kind of the description of what we're doing? So the idea here is I want to break this down into like a horizontal component and a vertical component. Everybody's okay with that notion? The reason if I do that, I can use the Pythagorean theorem to find the length, and I can use trigonometry to kind of calculate the bearing out of that, similar to what we've been doing. The question is going to be like, how do I do that? Well, if I take this horizontal component and I take that horizontal component and add them together, I should get that horizontal component, right? And if I take this vertical component and this vertical component together, I should get this vertical component. And that's going to be kind of the gist of what we're going to be doing. Now, I know that picture is like a bloody mess now, but it's not that useful in terms of like actually doing the computation that we're going to be doing, but I want to give you like an overview of what the approach is. Okay, so let's think of this as two phases. We're going to have the first leg of our trip. So I'm just going to redraw this with only the first leg on here. So that was a 215-degree angle. And then 35. So I'm going to convert that into a standard position angle. And I'm going to use a 1 subscript on this. Everybody's okay with what I've done so far? We're told that this is leg of the trip. We're going 40 knots for 2 hours. So our distance then is going to be 40 times 2, or 80 nautical miles. Is that okay? So that 80 nautical miles is representing the length of that arrow that we drew there, right? That's how long it is. In the standard position angle, our theta is representing like which way that arrow is pointing. Does that feel okay? So to break this down into horizontal and vertical components that I'm going to call x1 and y1 respectively, just going to do 80 times cosine of 235, and then 80 times sine 235. I'm always going to use cosine with the horizontal, and always going to use sine with the vertical. Everybody so far so good? Then I'm going to do the same thing now for leg 2. So for this one, our bearing was 162. So our standard position angle should be 90, 90, 90, and then 18. And this leg, we're going 55 knots for 3 hours. So the distance traveled this time would be 165 nautical miles. So the horizontal component for this trip is going to be 165 cosine 288, and the vertical would be 165 sine 288. Is that okay with what we've done so far? So that's just me breaking down the individual legs of our journey into vertical and horizontal components. So our final position then is going to be the sum of the horizontal, comma, sum of the verticals. So let's get the calculator out and punch that through. So first thing I want to do is change my mode back to degrees, because we're talking about things in angle or in degrees, since our angles are in degrees rather than radians. So I'm going to do 80 cosine 235 plus 165 cosine 288. So I get 510 and change for the horizontal component. And then if I do the same thing with sines rather than cosines, I get negative 22246 as my vertical component. John? So I don't have to worry about the negatives because I'm using the standard position angles. So if you had used 55, then you'd have to worry about making the sine and cosines negatives. But by using the standard position angle, we take care. The negatives are all taken care of for us. That's the advantage of using the standard position versus just like figuring out the angle relative to the x-axis with the bearing. Is that we don't have to worry about remembering negatives and positives and all that. So what this is saying then is that here's the port, and our final position, we're going 5 over and like 200 down. So our final distance is going to be represented by the length of that segment. Essentially going to be the distance between points P and F. In geometry, how did we find the distance between 2 points? Oh, the distance formula, fantastic. Remember what the formula was for the distance formula? Square root of x1 minus x2 squared plus y1 minus y2 squared. In here, though, what is our x2 and y2? It's the origin. It's 0, 0. So all that stuff's just going to drop out. And it's just basically going to become the Pythagorean theorem. Will that happen every time? As long as you're picking the origin to be the start of your trip, it would. And why you would not do that, I do not know. Maybe you just like making your life difficult. But that's what I would be doing. So I'll punch that into my calculator. Pa-pow! That's the sound of me punching. So that gives me 22251. And because the distances were in nautical miles before, obviously any distance I get now is going to be nautical miles. Be okay there? The other thing it asked for was my bearing. So that would be this right here. So this piece is 90, right? and then it's going to be plus this piece. What is that piece going to be called? Dude, that's an alpha, right? Between the terminal side and the x-axis, acute angle. That's an alpha, just like we did before. The question should be, should we be using sine, cosine, or tangent there? Tangent, because we know the x's and y's. Maybe let's write alpha, where alpha is tangent inverse, the absolute value of y over x and then it's calculator time. And here I am actually going to use the absolute value command because I'm just going to pull the y value from here and the x value from here, so I can't like unnegative it real easy. But I get 178.7. So there's my bearing. Okay, let's do one more. So this one's a little bit trickier. So here it says a plane can travel 480 miles per hour under its own power. The pilot sets a bearing of 320 degrees. As the plane travels, the pilot notes that the plane is actually traveling at a bearing of 325 degrees and a speed of 472 miles per hour. What is the bearing and direction of the wind? Well, if we think about this, how is the initial settings for the plane, the wind, and the final settings for the plane going to interact? Right, the wind is going to affect the initial settings to give you the final settings for the plane. Everybody agree with that? So if I'm interested in the wind, I know I'm going to be having to take the final settings of the plane and subtract the initial settings. Everybody okay with that? So my final settings for the plane, it said the bearing was 325 degrees and the speed was 472. But initially we set a bearing of 320. And we had a speed of 480. Everybody okay? Just from reading comprehension, we can imagine what's going on here, I hope. Okay. So I'm going to start the same way. I'm going to start by taking the bearing and converting those into standard position angles. So there's my bearing. So I had 90, 90, 90. And then 55. So my theta there then has to be 90 plus 35, so 125. And for the initial, we're over here at 320, so 90, 90, 90, and then 50. So my theta there then is going to be 120. No. Great googly moogly. 130. Everybody okay with that? We don't know how long the plane is traveling, but that doesn't matter because we have the speeds. So the final speed is just 472. The initial speed was 480. So we're just going to use that. Since there's no times given to us, we don't get distances, but it's not asking us in the question for a final distance. It's asking us for a final speed. So that's okay. And here's the thing that's going to be different, is that my wind is going to equal xf minus xi and yf minus yi. Rather than being additive, these are being subtracted based on the reasoning that we established before, that the wind is affecting the initial to give you the final. So then it's just calculator time. So 472 cosine 125 plus 480 cosine 130. Oops, I didn't mean plus, though I meant minus. And then same thing except signs. So 37.8 and 18.9. So the speed for the wind is just going to be the distance formula. But really, because the origin is the starting location, it just simplifies down to the Pythagorean theorem. So that's 42.3 miles per hour. Ooh, windy. And if we think about what we did here, if we plot this point, this is our wind here. So that's our bearing. So that the bearing, this was 90 degrees. There's our alpha. So our bearing is just going to be 90 minus alpha, where the alpha is tan inverse of y over x. And it's calculator time. I'll move this over here. And notice here that I'm not bothering with the absolute value because everything is positive. I guess I should write that in, though, on our work here, absolute value. So that gives us 63.4-ish. Everybody okay, relatively speaking? At this point, you guys should be able to do worksheet 7, as well as problems 24 through 31. that'll be part of the problem set after. So this week's problem set is worksheet 1 through 23, worksheets 3 and 4. Next week's problem set is going to have worksheet 7 and these other problems. On Friday is the asynchronous day. That's going to be your review day to work on your review packets and just kind of get caught up on things. So there's no lecture, there's no new assignment, just like get your stuff caught up. Time. We'll see you guys again Tuesday next week. On Tuesday, we'll take questions from stuff, the review, whatever. Talk about the test format, start chapter 5, and then Thursday will be the test day. I want to make sure we get a time in there in between now and the test to ask some questions. Everybody okay with that plan? Okay. Cool. Sound good.